Hi, this is Wendy Lightheart, and today we're going to learn about negative exponents and scientific notation. The negative exponent rule says that if b is any real number other than 0 and n is a natural number, then b to the negative n is equal to 1 over b to the positive n. So note that the negative sign on the exponent does not change the sign on the base b, it only changes its location. So the b to the negative n is technically in the numerator since there is no fraction bar on that side. But we can rewrite that by moving that base of b to the denominator, and that changes the exponent to a positive exponent. So for example, let's write x to the negative 4 with positive exponents. So currently it's in the numerator, so we can move it to the denominator and change the exponent from a negative 4 to a positive 4. And then of course we always have to put a 1 in the numerator if it would be empty otherwise. So that's our final answer. What about 5 to the negative 3? Let's rewrite that with positive exponents. So again, since there is no fraction bar, the 5 to the negative 3 is in the numerator. So we can rewrite it with a positive exponent by moving it to the denominator. That changes the exponent to a positive 3. And we put our 1 in the numerator. And then of course, if the base is a number, we can simplify further. So we always want to make sure that we simplify as much as possible. So 5 cubed is equal to 125. So our final answer is 1 over 125. How about this example? We have a negative and then a 3 to the negative 4, and we want to rewrite that with positive exponents. So that base here is the positive 3. That negative sign that's out front is not being raised to a negative 4th power because it would have to be inside parentheses to be included in that power. So the negative sign, notice, just stays in front in each step. And then to change the exponent of negative 4 to positive, we simply move that base of 3 down to the denominator, change the exponent to positive, and then we put our 1 in the numerator because we can't leave the numerator empty. And of course 3 to the 4th can be simplified to 81, so our final answer is negative 1 over 81. Here's an example where the negative sign is inside parentheses, so it's being included in the power. So it's a base of negative 2 is being raised to the negative 4th power. So the base of negative 2 gets moved to the denominator, and the exponent changes from negative to positive 4. And we put a 1 in the numerator. And then we can simplify that, since negative 2 being raised to the 4th power means negative 2 multiplied times itself 4 times, and that's equal to positive 16. So our final answer is positive 1/16. So here's that rule that we saw already, the negative exponent rule. B to the negative n equals 1 over b to the n. But this also applies to a base originally being in the denominator. So if we have 1 over b to the negative n, for example, the negative on the exponent, remember, tells you that you can change the location of the base and then change the exponent to positive. So 1 over b to the n, we're going to take that b that's in the denominator and move it to the numerator, and then change the negative n to a positive n. So we have b to the positive n. And remember that the sign of the base does not change. So here's an example where we want to rewrite this expression so that it only has positive exponents. So think about what are the bases. What is being raised to a negative exponent? Those are the things that are going to be moved. So the y to the negative 3 is going to move from the numerator to the denominator, and that becomes a positive 3 exponent. And then the x to the negative 2 that's in the denominator will get moved to the numerator, and that exponent changes to positive. And then note that the 2 and the 5 did not move. This is because those numbers are not being raised to the negative exponent. Only the x and y were being raised to a negative exponent. So those are the only things that got moved. Here's an expression we need to simplify. So we're going to need to get rid of those parentheses. So notice we have a product of 2 times x squared inside the parentheses, and that's being raised to a power. So first we would need to apply the product to power rule. So that means we need to cube both the 2 and the x squared. We can cube the x squared by applying the power to a power rule, which says we need to multiply those exponents together. So that gives us 8, because 2 cubed is equal to 8, and then x to the 6th, and that's again from multiplying those exponents of 2 and 3 together. And then notice we have a base of x in the numerator and a base of x in the denominator. So now that we've gotten rid of the parentheses, the next thing we need to do is to combine those bases into a single base of x using the quotient rule. The quotient rule, remember, says to subtract exponents, top minus bottom. So that would give us an exponent of 6 minus 8, which is equal to negative 2. The result of the quotient rule, remember, always goes in the numerator. So we have x to the negative 2 in the numerator, but we can't leave negative exponents on our answers when we're simplifying algebraic expressions, so we can take care of that by moving that base of x to the denominator, and then the exponent of negative 2 changes to a positive 2. And that will be our final answer. Now let's take a look at scientific notation. Scientific notation is written as a times 10 to the n, where a is some number between 1 and 10, and n is an integer. If we want to convert from scientific notation to decimal notation, then if the exponent n is positive, we will move the decimal point that many units to the right. So for example, 6.17 times 10 to the positive 5 exponent means we're going to move that decimal 5 units to the right. So 1, 2, 3, 4, 5 units to the right. Notice we have 3 spaces that we're going to need to fill in with placeholders of zeros. So we insert those 3 zeros and we end up with 617,000. On the other hand, if the exponent n is negative, that means we're going to move that decimal point to the left, and it's going to be the absolute value of n units to the left. So 5.75 times 10 to the negative 3, for example, if we want to rewrite that into decimal notation, that means we're going to take that exponent and move it 3 places to the left. 1, 2, 3. And notice we have 2 spaces that need to be filled in with zeros. So we end up with 0.00575. Now let's look at converting from decimal notation to scientific notation. So our first step is to determine the a, which needs to be a number that's between 1 and 10, and then find where the decimal point must be moved to obtain that a. Then you count the number of decimal places and the direction needed to move from the final location to its location in the original number. If you moved right, then n is positive. If you moved left, then n is negative. So for example, let's write 0.012 in scientific notation. So our a will be 1.2. If we put the decimal point between 1 and 2, we get a number between 1 and 10, so that's going to be our a. Then we would have to move 2 places to the left to move from where the decimal needs to go to where it is in the original number. So that means our exponent of n is going to be negative. So we end up with 1.2, which is our a, times 10 to the negative 2. Let's write 356,000 in scientific notation. So we locate our a first. So if we put the decimal between the 3 and the 5, we end up with 3.56, which is a number between 1 and 10. So that's going to be our a. We would have to move 5 places to the right to move from where the decimal needs to go to where it is in the original number. So our exponent is going to be a positive 5 on our 10. So that gives us 3.56, which remember is our a, times 10 to the positive 5. Now the whole reason why we're learning this right now is because we can use the rules of exponents that we've been learning to perform operations between numbers that are in scientific notation. So first we'll look at multiplication. When multiplying numbers that are in scientific notation, we multiply the a's together, and then we multiply the powers of 10 together using the product rule. And if necessary, you might need to convert your result to proper scientific notation depending on what size your a times your two a's multiplied together give you. So here's an example of two numbers that are in scientific notation, and we want to multiply them. So that see that this is all multiplication. So basically what we're doing is we're reordering and regrouping. So we put the a's together, we're going to multiply those together, and then we can put the powers of 10 together so that we can use the rule of exponents. So 2.5 times 3.1, that's our 7.75. And then when we multiply the powers of 10, we use the product rule, which means add the exponents. And when we do that, we get a 2 for our exponent on the 10. And that is in proper scientific notation, since 7.75 is between 1 and 10. And so that's our answer. Here's another example. So here we multiply the a's together, and then we're going to combine the powers of 10 together. 5.7 times 6 is 34.2. And then when we multiply the 10s together, we add the exponents. So we end up with a negative 5 as the exponent on the 10, but the 34.2 is not between 1 and 10. So what we can do to put it into proper scientific notation is to rewrite the 34.2 in scientific notation. So that gives us 3.42 times 10 to the 1. And then we can combine that power of 10 with the other power of 10, which is 10 to the negative 5. So we're going to add those exponents together on those powers of 10s to get a final answer of 3.42 times 10 to the negative 4. Now let's look at division with scientific notation. So here we have 6.4 times 10 to the 9 divided by 3.2 times 10 to the 2. So both those numbers are in scientific notation. So we approach this very similar to the multiplication. We divide the a's separately, and then we divide the powers of 10 separately. So if we divide 6.4 by 3.2, we get 2. And then to divide the powers of 10, we use the quotient rule for exponents. So we're going to subtract the top exponent minus the bottom exponent. So that'd be 9 minus 2. And that becomes a positive 7. And notice that 2 is indeed between 1 and 10. So that is in proper scientific notation. And that is our final answer. So that's it for today. Have fun working with those rules of exponents.